Let's remember back to when you did long division with just integers. So let's say we had 100 divided by 19. You asked yourself, how many times does 19 go into 100? And the most that can go in is 5. Then what you did is you took 5 times 19 and you got 95. You then subtracted these two values and you got 5. So your answer was 5 with a remainder of 5. So we're going to apply the same concept except with polynomials. So if I gave you the problem x squared plus 7x plus 12 divided by x plus 4. So the polynomial x squared plus 7x plus 12, this is called the dividend. It is what is being divided. And this value in front is our divisor. It is what it's doing the dividing. And then our answer up here we know is called the quotient. Okay, so let's walk through the steps on how to divide polynomials. Your first step is to take the first term in the dividend and divide it by the first term in the divisor. So, x squared divided by x equals x. So, this is part of the quotient. And what I do is I always like to have my variables all lined up, or my like terms. So since x is a linear term, I'm going to put it above this 7x because that's also a linear term. Then we take x and we multiply it by x plus 4, and we get x squared plus 4x, and that goes underneath our dividend. So we have x squared plus 4x. So just like we did before in our integer example, we are going to subtract these two. And since it's a polynomial, you need to include parentheses. X squared minus x squared is 0. 7x minus 4x is 3x. Our next step then is to bring down this 12. And then we repeat the process. So we take the first term, 3x, in our new part of our dividend, divided by x, and we get 3. And then we take 3 and we multiply it through the whole x plus 4, and we get 3x plus 12. And when we subtract, we get 0. So our final answer is x plus 3. Now notice that my quadratic terms are all lined up, all of my linear terms are lined up, and all of my constants are all lined up. That's important. You want to keep them aligned vertically. Okay, so because there is no remainder, this means that we can say that x plus 3 is a factor of x squared plus 7x plus 12. And you know this because if we were to check, what you're going to do is you are going to take the quotient, which was x plus 3, multiply it by the divisor, x plus 4, and you should get your dividend, which in this case we do. So it's quotient multiplied by divisor should equal your dividend. So let's look at an example where we will get a remainder. I'm going to use the same dividend, x squared plus 7x plus 12, but this time I'm going to divide by x plus 2. Now I know x plus 2 is not a factor of this because I just told you it was x plus 4 and x plus 3. So we will definitely have a remainder. You're not always going to know this right away, but we know for this problem that we will. Alright, so I'm going to take x squared divided by x, and I get x, so that goes over the 7x. Then we take that x and multiply it by x plus 2, and we're going to get x squared plus 2x. Then we add in our parentheses and subtract. X squared minus x squared is 0. 7x minus 2x is 5x. Then we bring down the 12. Now we repeat. 5x divided by x is 5. Multiply 5 times that x plus 2, and we get 5x plus 10. Parentheses when we subtract, which means that we are going to have 5x minus 5x, which is 0, and then we have 12 minus 10, which is 2. Now, the proper way to write this as an answer, it's going to look different, but this is the proper way. You write the quotient and then you add the remainder value over your dividend. So this is the final answer to that division problem. So, if I wanted to check my answer, what I'm going to do is I'm going to take my quotient, I'm going to multiply it with my divisor, just like before, but now that I have a remainder, that is added, so plus your remainder, and that's going to equal your dividend, what you divided to start with. So it's the same check, quotient times divisor, but then you just add that 2 back in. So one more thing with dividing polynomials that can make it a little difficult is that we need to put in placeholders when we need them. So a placeholder comes into play whenever we have a term or a term that's not given. So for example, if you notice in our dividend right here, we are missing our linear term. It just goes from x squared to a constant. So I don't want to put in a number because that would change the problem. But we're going to use 0 to kind of hold the place of that linear term. So I'm going to set up my problem like this. 9x squared plus 0x plus 1. And then I'm going to divide by 3x minus 2. So if you forget to put a placeholder in long division, you will catch your mistakes. And finding that mistake is also why I like to vertically line up all of my like terms, because you will catch the mistake that way. So it's really important this needs to be here. If not, things aren't going to line up and you're going to run into some issues and you're not going to solve the problem correctly. All right, so we're going to take this 9x squared divided by 3x. And I'm going to get 3x. Now that goes over that linear term, and if you didn't have that placeholder there, right away you would have been asking yourself, well, where do I put it? There's no linear term. I can't put it over anything. So we have that linear term, so it goes right there. And then we're going to take 3x, and we're going to multiply it by 3x minus 2, which equals 9x squared minus 6x. Parentheses and subtract. 9x squareds add to 0, and then we have 0 minus negative 6, so we're going to get plus 6x. I'm going to pull down that 1, and then we do the process all over again. So we have 6x divided by 3x, and I get 2. I take that 2, I multiply it through, and I get 2 times 3x minus 2, and I get 6x minus 4, and I subtract. And I'm left with 1 minus negative 4, which is plus 4, so 5 is our remainder. So our final answer is written 3x plus 2 plus 5 over our divisor. The last thing I want to note is that you can have this placeholder anywhere. It can either be in the dividend, like in this example, or you might even need a placeholder in a divisor. So you need to check the dividend and the divisor to see if you need to put a placeholder in there. Lastly, keep in mind that another way to check to see if things are going okay is that we started with a quadratic, and then we divided it by a linear term, which means we are going to end up with a linear term or polynomial like we did. So if I had a cubic and I was dividing by a linear term, then I would get a quadratic. If I had a quartic, which is a degree of 4, and I'm dividing by a quadratic, which is a degree of 2, then I'm going to get a quadratic as my quotient. So these are a bunch of tips to kind of help you see along the way if you're doing this correctly and if your answer makes sense.